take R, R and R separately to take genotypic ratio. So when we did monohybrid cross, you remember that this was the F1 generation parents, F2 generation parents which we crossed. So it will be R is to capital R small r is to small r, right? And the ratio was 1:2:1. Similarly, for Y and YY, be capital Y, small r, okay? So be capital Y is to capital Y is to small y, small y. So this ratio is also 1:2:1, right? So when we have to find genotypic ratio, I'll take R, this capital R here, and capital R small r here, and this small r here. Okay. So this ratio was 1, and this ratio was 2, and this ratio was 1 again. So it will be 1. I'll take this Y over here in all the boxes. Y, capital Y, small y, small y, small y. This was 1, 2, 1. Capital Y, small y, small y, small y. And again we have capital Y, small y, and small y, small y. 1. Okay, so just a quick recap. We're finding genotypic ratio here. For that, my F1 generation in dihybrid cross was RRYY and RRYY check, whichever check. Here, F1 generation. Right? So this is the F1 generation. From this I find the genotypic ratio here. So F1 generation is this and this. So I'm taking this one and this one for once. Okay. And if you remember in monohybrid cross, we did this Punnett square thing. It was R. This thing, this thing. It was this, right? So it was similar, right? So that is why when we did this ratio, genotypic ratio which we got was 1:1, right? So I'm taking R is to R is to small r, okay? 1:1. Understood? Similarly for Y also, we'll get the same thing. 1:1. Okay? I'm finding the genotypic ratio now. Take this R here, this first one and second one and third one. Okay? And then we have Y, capital Y, small y, small y, small y. Similarly for everything else. Okay? So here, what will be 1 into 1? What is 1 into 1? 1. 1 into 2? 2. 1 into 1? 1. 2 into 1? 2. 2 into 2? 4. 2 into 1? 1 ones are 1, 2 ones are 2, 1 ones are 1. Okay. So ultimately our genotypic ratio will be 1:2:1 is to 2:4 is to 2:1 is to 2:1. Okay. This is the genotypic ratio. See, 1:2:1, 2:4 is to 2. Okay. 1:2:1. Okay. You understood this genotypic ratio finally? That's all. And we have numericals. Before that, I want to ask you a question. You have 1,000 seeds with you. How many wrinkle green seeds will you get? I've given you 1,000 seeds. Okay. How many wrinkle green seeds will you get from 1,000 seeds? What is the See, 16 seeds gave 1 by 16, right? So it gave 1 quintal seed. So 1000 seeds into 1 by 16. Okay, so that many quintal seeds you get. This is one type of numerical. Similarly, they might ask you for 100 seeds. Find from 100 seeds. Okay. You read down from table. So this was our genotypic and phenotypic ratios. We'll go to numericals now. I told you in the starting of the chapter only that there are so many numericals in this chapter. Okay, it's very basic numericals. And this is just a proof for we found the genotypic ratio just now. So genotypic ratio I found from monohydrate genotypic ratio. I found it from that only. No, I took 1:2:1, and then I found the dihybrid genotypic ratio. Similarly, we will prove for phenotypic ratio also. Okay. Proof of phenotypic ratio of dihybrid. The dihybrid monohydrate genotypic ratio was 3:1, right? And again 3:1. This is for R, R, Y, Y, R, R, Y, Y. Okay. For R and R, it is this. 3 3s are 9, 3 1s are 3, 1 3s are 3, 1 1s are 1. Okay. This is the phenotypic ratio, right? This is phenotypic ratio of monohybrid, and this is phenotypic ratio of dihybrid, right? So you understood this? 3:3 9, 3:1 3, 1:3 3, 1:1. Sorry, 1 into 1 is 1. Okay. This is the proof. The most important topic or most important parts of this chapter is numericals. Okay. Do you want to go to your PowerPoint now? So first one is number of gametes. Okay. So when I took RR, YY and RR, YY, okay, I found 4 gametes in this room. Dihybrid cross, I found 4 gametes in this and 4 gametes in this. But what if they give you something like AA, BB, CC, D and D? Okay. So you can't find it like so many gametes will be there. So you can't find the number that easily, right? So a method to this formula is 2 to the power n. Okay. This n is number of heterozygous traits. Okay. So this is heterozygous. So 1, and this is homozygous here, this heterozygous, and 1. So my n is 2, right? Do you have any doubts? See, homozygous is this, or homozygous is this, heterozygous is this. Yeah. Right. So this is heterozygous, this is heterozygous. So heterozygous is 1, and this is homozygous itself. Yeah. And this is heterozygous, this is homozygous. 2. So 2n is 2. So 2 to the power 2 is 4. So 4 gametes will be formed from this. Okay. We'll find for this also. See, RR, RY, this was the dihybrid cross rate which we took. So here this is also heterozygous, this is also heterozygous. 2 to the power 2 is equal to 4. Yeah. Heterozygous 1, heterozygous 2. So 2 goes n is equal to 2. So we have n square is equal to 4. Okay. Find for this TTRR. There is no heterozygous, so it's 1, that's all. So 2 to the power 1 is equal to 2. Okay. And then we have number of progeny or zygote or offspring combination. Okay. So what we have to do here is, suppose we have two parents, RR, YY, we do it for monohybrid, so dihybrid. Okay. So then you have a better understanding. Here, you have to find number of gametes first. This is the second one. And the second one is number of offsprings or progeny. Okay. Number of gametes for this. And this one also number of gametes. So how many number of gametes will be there? 2 to the power n, and this is 2, so it will be 4, which is nothing but 2 to the power 2 is equal to 4. Right? So this is gametes. Okay. And here also it will be same. Right? So 4 is gametes. You understood this? So after this is 4 into 4. Okay. So how many offsprings did we get in the monohybrid? That's the formula. Okay. So when we take for AA or when we take for round, wrinkle, violet. Okay. Into crossing between this one again. B. Okay. So what are the gametes here? 2 to the power n. So this are homozygous, heterozygous. Right. So 2 to the power 2 is 3. So here heterozygous 1. Here heterozygous is 1. 1. So 3. 3, right? So 2 to the power 3 is 6. Sorry, 8. So that 2 to the power n is equal to 8. Right? So for number of offsprings, 8 into 8 is 64. So number of offspring will be 64. Okay, understood. So this was our second formula. We'll do non-Mendelian first. Okay. where of the same type, right? So give me some monohybrid Mendel cross example parents. And sorry, dihybrid. Give a dihybrid. See, it was R. No? Yeah, everything is fine, but then I'm just asking you to give parents, so you're taking so long. RRYY into RRYY. So he was taking one dominant and one recessive. Right? Yeah. So what he did was, this was Mendelian parents. Mendel cross parents. Okay. How will you find the difference between Mendel's cross and non-Mendelian crosses? In non-Mendelian cross, we'll have something like A, B, 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 A, B. Okay. See, here this is dominant and here this is recessive, this is recessive. Right, so this is non